Hello, I'm Deepa Mathur, Lecturer Instrumentation, GPC Kota. In this video, I will be discussing the basic concepts of signal flow graph, which is a unit of the subject control theory, IE 303 for final year instrumentation. Here you can see we've got two diagrams. One which represents the closed loop system in its block diagram format, and another which also represents the closed loop system in a signal flow graph format. So this diagram all of you all should be knowing by now, but anyway, just to brief it, you can see that this is a closed loop system, meaning to say you've got RFS, which stands for the reference signal, EFS error signal, GFS the forward loop gain, CFS the output signal, which is the controlled output signal, HFS the feedback gain, BFS the feedback signal. Here this is the comparator which compares the RFS and BFS. Compare matlab meaning that it's going to get subtracted. So EFS is the result of RFS minus BFS, and the same system is going to be represented in the signal flow graph format. So the signal flow graph is essentially just an alternate to the block diagram, nothing very different. The signal flow graph also represents a set of simultaneous linear algebraic equations, just like the block diagram representation that we have studied until now. So the difference here is basically we do not have blocks, we've got nodes instead, and we've got branches. So let us see what is the meaning of node, branches, how is the gain represented here if we do not have blocks. Let's go step by step. All the definitions that I'm defining here, I have given it to you in the following two slides. You can go and take it down from there. So here, what I would like to tell you here is all the signals over here are represented as nodes. So let's see what's a node. All the red spots that you're seeing here, they are all nodes. Okay. So node is a point which represents a variable or a signal. Okay. So let's see once again. All the red points are nodes. Node is a point which represents a variable or a signal. So RFS, EFS, CFS and BFS, these are signals represented as nodes. Here RFS, EFS, CFS and BFS. So now you know what a node is. So next, what is a branch? A branch is a line segment which joins two nodes. Okay. A line segment which joins two nodes, these are branches. Okay. Now we have got a small difference over here. Here the gain is represented in boxes or in blocks. Here the gain is represented as arrows. All the green arrows that you see here, they are the gain of the system here. All the green arrows are the gain between two nodes. Okay. So here you've got this gain is in between EFS and CFS. Here between EFS and CFS, this is the gain. Here the gain is going to be called as transmittance and not as gain. Okay. In signal flow graph, the gain is called as transmittance. So the gain between two nodes is called as transmittance and represented as an arrow. The other gain here, HFS, between CFS and BFS. Between CFS and BFS, we have got HFS, which is represented as a green arrow. That is also the transmittance, the gain between two nodes. Okay. Now you've got another few arrows over here, that is the green arrows. Here it is 1 and 1 because between RFS and EFS we do not have any specified gain, so it is just multiplied by 1. So we're getting same RFS here. Next, here also I've just taken an extension of CFS over here, so there's no change in the signal value, so it is multiplied by 1. And here of course I have marked it as minus 1 because though between here we do not have any more gain, but it is going to the negative terminal of the comparator. So therefore it is multiplied by minus and you get minus 1 here. So I hope I am clear with the transmittance. Next, let's go and learn a little more about the nodes. We've got three different types of nodes here. Let's take the input and the output first of all. You know that this is the input RFS and this is the output CFS. So an input node only has outgoing branches. Okay? And an output node has only incoming branches. So any node which has got only outgoing branch is called as an input node, or it is also called as a source. Okay? And any node which has got only incoming branches is called as a output node, or it is also called as a sink. Okay. So now we've got another type of node here, this, and this. These three type of nodes are a little different than the input and the output node because it has got both incoming as well as outgoing branches. Let's talk about E of S. This node has got one incoming, another incoming and one outgoing. What about C of S? It has got one incoming and two outgoing. What about B of S? This has got one incoming and one outgoing. So those nodes which has got both incoming as well as outgoing branches like these, they are called as mixed nodes. Okay? Okay, so that's about it. Next, let's see what is the meaning of a loop. Loop you already know, we have done loops here. Loop, it starts at one point, ends at the same point, that is called as a loop. A loop is a closed path. Here, say a loop is a closed path. You know, it's a closed path. So a loop is a closed path, starts and ends at the same point. So what is a loop gain? If you multiply all the individual transmittances of which is appearing in a loop, then you get the loop gain. So the loop gain is the product of the branch transmittances. Whatever branches are available in the loop, all those branches, whatever gain is there, if you multiply, you get the loop gain. So here we have got only one loop, and what will be the loop gain of this? It will be G of S multiplied by H of S multiplied by minus 1. Therefore, the loop gain here is minus of G of S H of S. Okay. Now when you go ahead, when we are going to go ahead with numericals or the next part of the signal flow graph, that is the Mason's gain formula, we will have new terminologies which we will be using. Just to give you an introduction about a few things which is a little different over here. We've got something which is called as non-touching loops, which we will need when we will be doing Mason's gain formula. So non-touching loops means loops which does not have a common node. Meaning to say, if supposing I have a loop which starts from here and ends here, for example, so this will also be closed, but I mean assuming that there is another node here, okay? But since we have a common node here, that is not a non-touching loop. But if I have a loop here, for instance, so a node here and a loop here if I have, then this and these are paths which do not touch each other. So then if these two paths or these two loops do not touch each other, then they can be called as non-touching loops. So non-touching loops are those loops that do not have any common node. Okay. Forward path, you know, the path with from the beginning to the end, that is called as a forward path. That means from the input node to the output node without crossing any node more than once. That is called as a forward path. Let's see once again. Forward path is the path from the input node to the output node without crossing any node more than once. That is called as the forward path. Okay. What is a feedback path? Closed loop is always called as a feedback. So what is a feedback path? It starts at one node and ends at the same node. That is called as a feedback path. Okay. A path which starts at one node, ends at the same node, that is called as a feedback path. So here in this case, and what will be the forward path gain in that case? All you multiply all the products of the forward path, that will be the forward path gain. Feedback path gain, multiply all the gains in the feedback path. So what is the forward path here? If you have to write down the forward path here, you will have to write down R of S, E of S, G of S, C of S, because This is the path. Okay, and if you want to write the feedback path, it will be, from here to here. So the details of that I will deal with in the next segment or in the next video that I will be continuing for signal flow graphs, that is for Mason's gain formula and all the numericals that we will be dealing with. All that I have explained in this slide, I have given it to you. Here I've given you certain things that you have to note, and also the definitions, all that I had explained till now, all of these that I had explained, I have given it, and also in the next slide here, all these things also I have explained. So if you will understand the basic concepts, the basic definitions, the basic diagram of signal flow graph with respect to the block diagram, it would be very easy when we go and study the Mason's gain formula as well as do the numericals and simplifications of those problems. So see you in the next video. Until then, thank you.